We will now be doing exercise 11.4, which is dealing with problems on the topic of volume of a sphere and volume of hemisphere. Okay, so in this particular class we are going to do the first 5 problems of this exercise 11.4. The first question is to find the volume of a sphere whose radius is 7 centimeters. So what is the formula for the volume of a sphere? Let's write down the formula. Volume of sphere is 4/3 pi r cube. And for solving these problems, unless specified with other values, we will have to use the value of pi as 22/7. Okay, unless it is given as 3.14, we will normally use the value of pi as 22/7. So the formula for the volume of a sphere is 4/3 pi r cube, and the value of the radius is given as 7 centimeters. So r is equal to 7. So let's write that down. Given radius r equals 7 centimeters. So therefore volume, we can substitute now the value of r into the formula for the volume, so which is 4/3 into 22/7 into r cube, that is r into r into r, that is 7 into 7 into 7. Okay, so we can have one of these 7s cancelling out each other, so that's 1 7 cancelling it out each other. So that gives us on the numerator we have 4 into 22 into 7 into 7, which is 4,312. So when we multiply all the numbers on the numerator, we get 4312. So that's 4312 divided by the denominator. We have only one number there, which is 3. So 4312 divided by 3 is 1437.333. Okay, so we can make this division. Okay, I'm not going to show how to divide these numbers. So when we divide 4312 by 3, we get 1437.333, and the unit for the volume is going to be centimeter cube, because the radius is given in centimeters. So the unit for the volume will be centimeter cube. Okay, so it's a fairly straightforward exercise problem where we have to directly apply the formula for the volume and substitute the value of the radius into the volume formula and make the calculation. We get the volume of the sphere. Okay, let's move on to the second problem, where we are told that we have to find the amount of water displaced by a solid spherical ball of diameter 28 centimeters. So the amount of water displaced is going to be equal to the volume of the spherical ball which is displacing that water. So basically this is an indirect way of asking the volume of the spherical ball. So the amount of water displaced is the same as the volume of the spherical ball. So that's the first thing we need to notice. So we'll write that down. Amount of water displaced equals the volume of the spherical ball. So basically we have to calculate the volume of the spherical ball. So again we will use the formula for the volume. So volume of spherical ball equals 4/3 pi r cube, which is we need to first have the value of r. So we are given the diameter of the spherical ball, from which we can calculate the radius of the spherical ball. So let's write down. Given diameter d equals 28 centimeter, therefore radius r is going to be half of the diameter, so which is 28 by 2, which is 14 centimeters. So we can now substitute the value of R in the formula for the volume. So volume is 4 over 3 into pi is 22 over 7 into R cube, that is 14 into 14 into 14. So we'll have one of the 7s going into one of the 14s 2 times. So we'll have now on the numerator 4 into 22 into 14 into 14 into 2 divided by 3. So we get 34496 divided by 3, which is equal to 11498.666. It goes on, it's a recurring decimal, 0.666. It will keep on going, so we can truncate at some point and make it 7, and the unit is centimeter cube. Because we are given the value of the diameter in centimeters, therefore the radius is also in centimeters. So therefore we have the volume of the spherical ball as 11,498.6667 centimeter cube. In other words, the amount of water displaced by the spherical ball is 11,498.6667 centimeter cube. Okay, so this is another way of asking to calculate the volume of a shape. So the volume of a shape will be the same as the amount of liquid or gas that is going to be displaced by that solid shape. Okay, so we have to use remember this sometimes that the volume will be asked indirectly by asking us to calculate the amount of something, some liquid displaced by some solid shape. Okay, so the amount of some liquid displaced by a solid shape is the same as the volume of that solid shape. So whatever is the volume of the shape, that will be the amount of liquid that is being displaced by that particular solid. Let's move on to the third problem. Here we are again given the diameter of a metallic ball as 4.2 centimeters. So from the diameter, we will be able to calculate the radius as half of the diameter. And we are asked to calculate the mass of the ball given its density. So we are given the density of the ball and we are asked to find the mass of the ball. Now to solve this, we need to know some information from our physics topics. What is the relationship between mass, volume and density? Okay, and the definition of density is mass per unit volume. So we need to have some background of the concepts in physics related to density. So let's write down that the formula for density is equal to mass divided by volume. Okay, so we are given the density of the ball of the metal, and we are also given the diameter, or indirectly we are also given the radius of the ball. So from the radius of the ball we can calculate the volume, and the density is given. So we have two quantities, density and volume, and using this formula we can calculate what is the mass of the ball, which is what we are asked to find. Okay, so the first step we will do is we will calculate the volume of the metallic ball. So I'll just write it as volume, and we will use our standard formula for the spherical ball. Because it's a ball, the shape is going to be a sphere, so we will use the formula for the volume of a sphere, which is 4 by 3 pi r cube. R is going to be 4.2 divided by 2. So diameter D is 4.2 centimeters. Therefore the radius R is 4.2 divided by 2, which is 2.1 centimeters. So now we can calculate what is the volume. So volume is 4 over 3 into 22 over 7 into 2.1 into 2.1 into 2.1. So I'm going to divide the page into two parts here, so we can do the rest of the problem on the other side. Okay, so we have now the expression for the volume of the metallic ball. So we can simplify a few things here. So you'll have so the 7 can go into this 0.3 times, and the 3 will go into this 0.1 times. So we'll have 4 into 22 into 2.1 into 2.1 into 0.1. So when we multiply all these numbers, we will get the volume of the metallic ball. So that gives us, this calculation will give us the the value of the volume as 38.808 centimeter cube. Okay, so we have got the volume now. From the volume, we can now calculate the mass of the ball using this relationship between density, mass, and volume. So from this relationship, we can now write the mass in terms of the density and volume. So we can write mass equals density into volume. Okay, so I have just rearranged this expression to get the mass. So we take the volume to the other side of the equal sign, so it goes to the numerator and gets multiplied with the density. So mass of the ball is density of the metal multiplied with the volume. So we now have all the information we need to calculate the mass of the ball. So density is 8.9 into the volume of the ball is 38.808. So that's 38.808, and that will give us the mass of the ball. So that product is equal to 345.3912, and the unit of mass is grams. Okay, so because we are given the density in grams per centimeter cube, the unit of mass is going to be simply grams. So the mass of the metallic ball is 345.3912 grams. Okay, so again here the problem involves knowledge of some concepts of physics related to density. So you need to know what is the relationship between density, mass, and volume. So if you know this expression, the first step is to calculate the volume of the metallic ball given its diameter, from which you can calculate the radius and substitute in the formula for the volume of the sphere and get the volume, and then use this relationship between density, mass, and volume to calculate the mass. Okay, so in order to solve this problem, you should be familiar with this expression or relationship between density, mass, and volume. Only then you'll be able to solve this particular problem. So let us now move on to the next exercise problem. Here we are given that the diameter of the moon is approximately 1/4 of the diameter of the earth, and we're asked to find what is the fraction of the volume of the earth, what fraction of the volume of the earth is the volume of the moon. In other words, we have to calculate what is the relationship between the volume of the moon and the volume of the earth. So what we have to do is we will use the formula for the volume of a sphere, because both the earth and the moon are spherical shape. So therefore we'll use the volume of the sphere formula. But let us assume now that the volume, that the radius of the earth is r, and the radius of the moon in that case will be 1/4 of r. Okay, because the diameter of the moon is given to be 1/4 of the diameter of the earth, it means that the radius of the moon will also be 1/4 of the radius of the earth. So let's write that down. So we have now diameter of the moon to be equal to 1/4 of the diameter of earth. Therefore the radius of moon will also be 1/4 of the radius of earth, because diameter and radius are related as radius is exactly half of the diameter So we are dividing both the sides by 2. So therefore the ratio or the relationship between the radius of the moon and the radius of the earth will be the same as the relationship between the diameter of the moon and the diameter of the earth. Okay, so we have now radius of the moon as 1/4 of the radius of earth. So what we now do is, let us consider the radius of earth to be r. So let's say radius of earth be r. So we'll denote it as r. So then what will be the radius of moon? Radius of moon will be r by 4, because we are given that the diameter of the moon is 1/4 of the diameter of earth, and therefore radius of the moon is 1/4 of the radius of earth. So if the radius of earth is taken as r units, then the radius of moon will be 1/4 of r, which is nothing but r over 4. So now we have the radius of the earth and the radius of the moon, and we can calculate what is the ratio or relationship between the volume of moon and the volume of earth. So what we will do is, we will write the expression for the ratio of volume of moon to the volume of earth. So both are spherical shapes. So the formula is 4 by 3 pi r cube. R for the moon, the radius value for the moon is r over 4. So it will be r over 4 cube. The whole thing divided by the volume of earth is 4 by 3 pi, and the radius of earth, we have taken it as r, so it will be r cube. So basically we have substituted the radius of the moon and the radius of the earth in the corresponding expressions for the volume of the moon and the volume of the earth. So since we have taken the radius of the earth to be r, so we have just put r cube in the volume for earth, and since the radius of the moon is r over 4, therefore the volume of the moon is 4 by 3 pi r over 4 cube. Okay, r over 4 is the radius of the moon in this context. Okay, so now we can cancel out a few things. So the 4 by 3 and 4 by 3 will cancel out, the pi and pi will cancel out, so we will be left with r by 4 cube and r cube. So what is r by 4 cube? We will have, that's r by 4 cube is r cube divided by 4 cube. 4 cube is nothing but 4 into 4 into 4, that's 64. So by 64 divided by, in the denominator here we have r cube, so we can rewrite this as r cube over 64 into the term on the denominator, which is r cube. If we take it to the numerator, it will become 1 upon r cube, so it is into 1 upon r cube. So now the r cube and r cube terms will cancel out, so we are left with just 1 upon 64. So basically what we are getting is the ratio of the volume of moon to the volume of earth is 1 upon 64. So let's write that down. So we get this ratio, volume of moon to the volume of earth is 1 over 64, or in other words, what this means is the volume of moon is equal to 1 over 64 times, so I'm taking the volume of earth from the denominator here to the other side of the expression here, so it's 1 over 64 into the volume of earth. So what we notice here is that the volume of moon is 1 over 64 times the volume of earth. In other words, the volume of the moon is the volume of earth divided by 64. That means the volume of the moon is 64 times smaller than the volume of the earth. So we are asked to find what fraction of the volume of earth is the volume of the moon, and that fraction is 1 by 64. Volume of the moon is 1 by 64th fraction of the volume of earth, and that is what we have been asked to find. Again, whenever we are asked to find what fraction or what is the ratio between two things, it is always easier if we just keep the value of pi and the other constant terms as they are, because when you take the ratio, those common terms will just cancel out and it will simplify our calculations. Okay, now to approach these kind of problems, you are not given any values for the radius. There is no value given for the diameter or anything. Okay, so you are only given a relationship between the radius of earth and radius of moon in terms of the diameter. So you have to think clearly and apply what is that relationship and use that relationship as it is. Okay, so in that case, what you have to do is you have to assume the radius of one of the objects to be some parameter, and then you have to formulate the radius of the other object in terms of the radius of the first object by using the relationship that is given in the question. Okay, so we are given in the question that the diameter of the moon is 1/4 of the diameter of the earth, from which we will know that the radius of the moon is also 1/4 of the radius of the earth. So we have to just assume that the radius of the earth is some parameter, and then correspondingly write the radius of the moon in terms of that parameter using the relationship given here. So in this case, the radius of the moon is 1/4 of the radius of the earth. So whatever we choose as the radius of the earth, the radius of the moon will be the radius of the earth divided by 4. Okay, and from there we can just use those parameters as they are in the formulae for the volume, and then we will see when we take the ratios, the common terms will cancel out and we will have a relationship between the volume of the two objects. Okay, so this is how we should approach these kind of problems. Let us do one more exercise problem for this video. So that's question number 5 from exercise 11.4, where we are asked how many liters of milk can a hemispherical bowl of diameter 10.5 centimeters hold. Okay, so basically we are asked to find how many the quantity of a particular liquid that can be held by a ball. So in this case, again, it's an indirect way of asking the volume of the hemispherical ball. So the quantity, the amount of liquid that can be occupied in a given shape is basically the volume of the shape. Previously we have seen in question number 3, we were asked to calculate the volume indirectly by asking how much is the amount of liquid displaced by the spherical ball and so on, right? So you have to understand what is being asked, because sometimes we asked indirectly, okay, as in this case here. So we are asked to find the quantity of the milk that can be contained in a hemispherical ball. In other words, we have to calculate the volume of the hemispherical ball. So the amount of milk that can be contained is the same as the volume of the hemispherical ball, and we know the formula for the volume of the hemispherical ball. Let's write that down. So we know the volume for a hemisphere is 2 by 3 pi r cube, which is exactly half of the volume of a sphere. We know the formula for the volume of a sphere is 4 by 3 pi r cube, and therefore for the hemisphere it's going to be 2 by 3 pi r cube. Okay, we know this formula. So basically we now have to calculate the volume of the hemisphere, and for that we need the value of the radius, but we are given the diameter. So from this we can calculate what is the radius. So because we are given the diameter, the radius will be half of the diameter, d by 2, which is 10.5 divided by 2, which is basically 5.25 centimeters. Okay, now from this we can now calculate the volume of the hemisphere. So I just write it as volume. So volume is 2 by 3 into pi. Pi is 22/7 into r cube, which is 5.25 into 5.25 into 5.25, and that will give us the volume in the units of centimeter cube. So when we simplify this this expression, or we make this calculation for all these numbers, we will get the volume as 303.1875 centimeter cube. So we get 303, so 303.1875 centimeter cube. Okay, that's the volume in centimeter cube. But notice that we are asked to find the volume in liters, so we need to convert this centimeter cube to liters. So we have to use the relationship between centimeter cube and liters. So what is the relationship? 1 liter is equal to 1000 centimeter cube. So we have seen this in the previous video as well. So 1 liter is equal to 1000 centimeter cube. So using this, we can now calculate the volume in liters. So we'll write volume in liters is going to be the volume in centimeter cube divided by 1000. So it will be 303.1875 divided by 1000. So that will give us, so because we are dividing by 1000, there are 3 zeros, so we can move the decimal point 3 places to the left. So we will get 0.3031875. Or we can simply write it as 0.303 and approximate it by ignoring the digits further on the right hand side of the decimal point. Okay, so it's we can keep just the first 3 digits or 4 digits, or we can leave it as it is, no problem. So that will give us the volume in liters. So the volume of milk that can be contained in the hemispherical bowl of these given dimensions is 0.3031875 liters. Okay, we'll stop here for today, and we'll continue with the remaining problems of this exercise in the next class. We have 5 more problems in this particular exercise, which we will do in the next class, and we will proceed after that to the subsequent chapter.